Okay. Today is our review day for exam 2. I thought the simplest way to go about this was just to go over our homeworks and work through those problems as needed. And that will give us a pretty good review. We can stop if you guys have questions about particular concepts, things like that. So I've made a list here of the content that we will be expected to know for the exam. So it starts at if-else statements and it ends with understanding, well, custom functions. That was the last thing that we did. So you don't need to worry about the dates thing or the strings that we learned last week. That'll be on exam 3. Okay. All right, so let's work through the exercises I gave you, and that'll help us kind of get warmed up for our test next Thursday or this Thursday. Okay, so first up is if-else statements. So during the guest lecture last month. Okay, so let's work through this first problem. Value of a number is positive. So remember, if-else statements have 3 main components to them. There's what should be the output if the answer is true, and what should be the output if the answer is false. Okay, so there are 2 different kind of types of if-else statements. There's a type that has it's in one line, and that's what the answer to this question will be. And then there's the second type that has it's more elongated. It's like if, condition, and then you have your curly braces, and then you else, and that kind of thing. Okay, but we'll do the simple one. That's the answer for this question here. Hello. I'm going to load tidyverse in my console here, so I don't use the base R. Okay, so make an object up. I'm going to call it V. I'll call it X. What's going to happen if it's true? Positive. And so this condition part requires a logic test. So this is where often our greater than or equal times or equal to come into play. So I'm going to define X, we'll define X as equal to -1. And there you go. All right, this is just a practice. We can set this question up as the other type of if-else statements. So this is the one with the curly braces. So we've already defined X, in this case, it's -1. And so it returns the answer again, positive, negative or 0. So this is very similar to the second, more complex kind of structure. We always have a logic condition at the top, so testing. And then the first part is always what happens if it's true, and then what to do if the answer is false. Okay, in this next question, it says, using the two objects, please generate an if-else statement that uses one of these logic operators. So we have to use two of these objects here. So unlike this question where we had one condition, we need to test two different conditions to answer this question. So we have two objects. All right. This makes sense. All right. Okay, so we're going to test the condition first. Is y not equal to 8? If that was true, in this case, we know that it is not true because y is equal to 8. We'll define this in a hot minute here. Do that now. Oh, no, don't move it. That's not what I wanted you to do. Then it's going to go to test this next condition, else. Get rid of that. It's an extra curly brace. And finish my sentence. All right, there we go. Break this down a little bit. Okay. You guys remember this? All right. All right. Number 3 can give, yes.
So for number 1, it's basically just saying, okay, so if this is true, then this happens. If it's false, then this happens. And then number 2 is if this is true, then this is what happens. But if this other thing is true, then that's what happens.
Yeah, it's like a series of conditions. So like, and yes, absolutely, you're correct. The way you described number 1, it's testing one thing. Here it's saying, okay, yeah, there's 2 tests involved. Is y not equal to 8? And then the computer's like, no, the answer is not true, right? So it's skipping over. This would be the output if the answer to the test was true. And so then it skips over to line. It's like, nope, not true. So then it skips to the next line where it has essentially a second if else statement that it's testing. So we're testing now, is x equal to 5? Test is false. Now our tests whether the second condition is true. So in this case, the condition was met. And so here now, the test was true. And so the positive result was returned. So this structure allows you to essentially, if you wanted to, you could test multiple things, right, in sequence. We use this too, because if we, let's say I'm just gonna highlight this for a second and make it not work correctly. If we wanted to try to emulate the number one answer, now I'm trying to put two conditions in that first test. It's going to be very unhappy because it could only test one. It's going to generate a warning. Should generate a warning. Oh, nope, not or. I'm asking you to do two things now. Oh man, it's just supposed to fail. Why is this not failing? Okay, so in most cases, I avoid doing this because I usually get a warning that says you're trying to test two conditions, only the first element will be used. Have you guys come across that? Yeah. I think this is working syntactically because it's correct, because there are two things, but like this structure, at least for me, 90% of the time ends in a warning. So I avoid it. I think that's actually funny. You get so, I think maybe burned by trying to do something that you just avoid it entirely. And then you come back later, you're like, oh, this is actually right. So anyway, this is why I avoid doing this. So, okay. So in question 3, I wanted you to create an if-else statement based on the Hamlet speech, to be or not to be. All right. So we want to create an if-else statement, whether he should be taking up arms against his sea of trouble. If you guys know the story of Hamlet, his family was quite dysfunctional. What's your problem? Dun, 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 dun. Okay. Unexpected. Oh, where's the oh? Where's the problem with the comma? No. Oh. Error. Unused argument. Oh, that's the problem. Doofus. I'm a goofball. My problem was this. I was using one equal sign and I need to use two. All right, there aren't that actually there are many variations on a very consistent theme, as you guys are saying here with these if else statements. All right, so go ahead and answer or copy whatever paste from your homework number 4. I'm gonna come around and take a look. Did you need to find it? You have to find the object. It's not- All right, raise your hands to like Andrew was on the pizza. Wow, a very ambivalent baby. Yeah. There you go. Okay. So this last question is about understanding some an error message. Okay. So this is what I was trying to avoid in the other one. The condition has a length of 1. So V has 6 values in it, and I'm asking it to evaluate whether V can be divided by 2. And So it's when you run this part, it generates 6 answers here. And so it can't evaluate it correctly because it's not doing it one at a time. So that's why it's like, this is not right. Okay. So the reason this generates an error is because it's trying to do 6 things at once. If I go back up here to where I was trying to make an error, and ironically enough did not succeed, here we're asking R to evaluate 2 conditions, but in a stepwise fashion, because it's separated by like an and, or we separated by an or, this vertical slash. So where we're saying, is y not equal to 8? It evaluates that. And then it also evaluates whether also x was equal to 5. So if both of these things, it's testing both of these things. So this is correct because it's doing one at a time. Here, down here, is trying to test 6 things simultaneously. Does that clear as mud? Okay. All right, does anyone have any questions about if-else statements? It's okay if you do. Yes.
For number 4, would you be able to like assign like anchovies to a number and non-anchovies to another number and then do it that way?
So let me see if I can do what you're asking me to do.
That's how I did mine a little bit.
So you did like anchovies equals,
Like 2 or something.
and no anchovies. Let's say equals what, like 4, 3, okay. And then what did you write?
And then I wrote if, and then I put the open parentheses, non-anchovies, 3. And then the curly bracket. And I put print like field and parentheses and then quotation marks.
Mhm.
And parentheses with the else. And the open bracket, and then I put print young.
Like this.
Put it in, yeah.
Okay.
And then the curly bracket. And then return what I want.
So it returned what you wanted because this, I'm not sure what. Okay. Did I do this part right, the way that you described it? Oh. So your question is, why did it do what you
Like, would I be able to do that?
Yeah, I think
instead
so.
of-
So
okay.
let's, I mean, because you're just assigning it. So your logic test here is you're just testing whether the object named no anchovies has a value 3,
Mhm.
and it does, right?
Right.
So that's why that was true. And so here it's going to return your ew condition statement. Yeah. So these can be powerful. Like, let's say you want to assign a value in a column based on a value in another column. So like, we had a data frame, and if we had a column already in there that had a particular species name, right? And we wanted to create another column that basically marked whether that species was present or not. Maybe you wanted to add them up. So you wanted a column that had a 0 if it wasn't that species name, and it was a 1 if it was that species name. Then you could be like, if column is equal to species name, and then assign a 1, otherwise assign a 0. Okay. All right. Actually, come back here. Oh, no. I'm just going to copy and paste this back into our class notes review so that we have it all in one place. All right, reshape data frames. So we went over exercise 7 in class, I think. Does anyone want to go over this again? Yeah. Okay. Is there a particular part that you want to tackle? Okay. 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 Yeah, because so I wanted to, yeah, why don't we come have a meeting? Because I want to make sure we go through the other ones because we didn't get through those yet. Okay. Yeah. Yes, sure. Come see me after class and we'll find a time today. Okay. All right. I'm gonna load up the batting data set because that's what we were using here. Oh, I didn't set my working directory, so I'm all kinds of lost. Go find it. Okay. So this question here is subset, player ID, these things, and a column. Okay. So there's two parts to this question because we're just repeating the process from number 2. So the first thing I need to do is subset the data just to get the astro information. So D, I think it's maybe D. Yeah. Okay, and I have to, melt is in the reshape 2 package, so I'm going to load that up. Okay, our input data is going to be our subset. In this case, it's called H. And so there are, let me go back here for a second. I got going too fast. There are 3 additional arguments that we need to pay attention to. The ID variables, those are the variables we want to keep as columns. The names of the columns in your input data frame that you want to go from wide to long. And then you're going to give the name of the column. These are optional here. This would be the new name of the column that contains all the things that you're melting. So in this case, we're melting. This is our ID. We're keeping that as a column. And we're melting the columns that contain this information. Okay. Here is our original data frame, just to refresh your memory. So we're working with these guys down here. So we're going to put all these values into a single column. All right, here I'm going to name. We're going to call this, I guess, hits. Hmm. Okay, so we've taken wide here. This is the wide format. And we've swapped it down so that all that is here. So this corresponds, this, for example, this top row here corresponds to this. So if I type unique HM hits, I'm going to get ABR3B, right? Because that's all what's going on right up here. These are the columns that we swapped over. Does that help? Okay. All right. Why did I do that? I want to save it. Ugh, Lord. Okay. So next on our list is merging data frames. Looks like I didn't do a specific exercise for this, but we've certainly covered it in class for a couple days. So let's review kind of the basic ways that you can push data together. So first function is cbind. Basically like creating one data frame from two sets of columns. Okay. Then we have rbind, which is the same idea, but we're just now smashing together rows. We have merge. And then we have join, which is like merge. Well, it's not join anymore. It's like, you guys remember, let's see, it's like left join. Oh, right here. You decide which rows, which data frames, rows to keep. All right, there are variations on the joins. So it can be a right join, can be an inner join. All of these are variations on this merge. So we'll see that in a second. You may remember in merge, it's like all x equals true, all y equals true. That is all about what's going on here. Let's see here. Keep all rows in the left data frame. Keep all rows in the right data frame. Keep all rows that match from both data frames. Okay. All right, so I harped on this a little bit when we were learning these. What is a danger about using cbind that differentiates it from merge or join, the join functions? Yeah. That is correct. So R will just willy-nilly smoosh things together. It doesn't matter if the data matches up. So this is the same warning here. All right, we already have our batting data loaded. So we'll make a couple things and we'll practice this for a hot minute. Okay, so I gotta split our batting data up into two separate things so that I can put it back together. I already have Houston, we'll do that. And then we'll get New York. So no, I need to split up Houston. That's what I need to do. H1. Ooh. Yeah. What columns do I want to keep? I'm going to keep home runs for this. Hits. And one more for good measure. We'll do birth year. And then I need to keep, I'm going to keep a key here. So I'm going to do player ID. All right, so there's one little data set. I'm going to make a second. At bats, RBI. Debut. Okay. All right, you guys walk me through this. How does this work? This one's very straightforward. All we have to do is type out the data frames that we want to smash together. So we're going to see, unlike join and merge, when we do C-bind, it's extremely literal. It's like, okay, I'll put these together. And so our player IDs are duplicated, right? If I had if I rearrange these, like I changed it by the alphabetical order, it would still put them together and it's like the match, it would not match up, right? Okay. We're going to use row bind. First, I need to get some rows. Okay, here's an example of using row bind. Houston has recruited a new player. So, see here, new player. We're gonna make a new data frame that only has one level. Player ID. We're gonna find these in a minute here. HR, H, and birth year. Okay, do this a little bit backwards. Player ID is going to be Okay, so I'm just making these objects. Where's my not found? No, oops, my bad. There we go. Okay. All right, so I just kind of created a little extra row of data here. So here I'm binding the rows from H1 with this little bit of here. Oops, what I wanted to do was tail, my bad. Just want to look at the bottom because that's where it went. There it goes. Okay. I'm going to mess up the order so that it doesn't match the columns of the data frame that I'm binding the rows to. I'm just going to repeat what I did on line 153. To drive home this point about it just kind of does it haphazardly. Ooh, what? Did you get fancy, Tar? Oh. There we go. That's the problem. It didn't get fancy. Who am I kidding? Well, shoot me. I did it right. Am I crazy? Let's see here. Arbine. That was unexpected. Well, okay. That's good to know. Must have been an update. Okay. This is why I'm always checking my work. Be sure you know what's going on. Okay. So what was supposed to happen is like in C-bind where it just kind of puts them together randomly, right? Because I did this out of order. So I thought it was going to be like, put the 1989 here, put like the player name here, and like put it in the wrong place. Yeah. Okay. So we still have two data frames. So we're going to use the merge function now to put these together. And so the by argument is going to use the values in our player ID column. So our first data frame is going to be H1. The second one is H2. Our by column, its name is player ID. And then we have an even number of data points or rows, excuse me, in each column. So this by argument is not particularly, this all argument is not particularly important, like it's all going to match up. But this becomes important if, for example, you have 10 rows in one data frame and like 5 rows in another. So there's an unequal, like some of them are not going to match up, right? So you have to decide whether you want to keep all the values in the 5 data row frame or you want to keep all the values in the 10 data row frame. That's where you say all X equals true or all Y equals true. That's where that becomes important. So this just defaults to all equals true. We can be explicit about it. So unlike the cbind function, as I mentioned earlier, we don't duplicate our player ID columns because it didn't just take two things and like literally like put them next to each other. It used that player ID column as a key to match up the data. So even if our data using this merge function, even if the values were like out of order in one, for example, if we had like sorted the names, it would have correctly matched up using that player ID column. So to repeat that using a version of the join functions, this is going to be called, it's going to be called an inner join. Here we go. Okay. In both of these cases, move this down so it's not, so it makes more sense. You can have multiple key columns. So for example, you could merge using like the team ID and the player ID. How are we feeling about merging? All right. All right, next on our list. Scroll up here. All right, we've done that one, that one. Okay, now we're on to custom functions. I don't want to keep putting the E after that one. I do not know. All right, so let's break down the syntax of a custom function. Starts with function. Okay. Name for me the parts that we're going to worry about here. Maybe the better way is like the structure. Okay, so the first thing we need to do is we have to define what the input arguments are going to be. Just like an already made function like merge that we just worked with, there are arguments that require input parameters for it to work. So in the merge function that we just worked with, we had to provide it with the data frame assigned to the X value, the data frame assigned to the Y value, and then what column or columns were going to be used as keys to put things together. So when we're making our own functions, we also have to define required input parameters or arguments to make it work. So if we were going to make like a temperature function like we practiced, right? We would need to have a single input, which is like, for example, if we were converting from Celsius to degrees Fahrenheit, our input would be degrees Celsius. Then we have the body of the function. Which is, it can be another function or series that does work. So let's see here, it can be an operation, mathematical operation. Okay. The body goes inside the curly braces. Okay. All right. So let's open up our homework. Let's see if we can use that to help us get oriented. This is using the little fish data set, so I'm gonna go ahead and load that. There's little fish. What's happening? This files. Pattern equals little cursive equals true. Oh, okay. Well, yeah, it was in there. All right. My computer is definitely lagging. I apologize. Struggle button right now. Okay. All right. So in this first question, it says we need to use the 2D dimensions of the frame to find the volume image using the data that's in the column parcel length M. Okay, so we need to write a function to do this. All right, we have to be mindful of our units, right? Because we have one set of dimensions that are in centimeters, and then parcel length M is in meters, right? So we're going to have to do some conversions so that we don't goof up our units. So let's go ahead and just turn our, ahead of time, we're going to use everything in meters. So instead of 50, it's going to be, right, 0.5. Okay. We'll call this image volume. And it's going to be in cubic meters. It's being the name. Okay, so our input parameter, the only thing that really is going to change and be dynamic is the value in our parcel length column. So we only have one input parameter, one argument. So now we're going to get to the body of the function. $50 times 13. So that's 5. All right, you guys check my work. Did I do that correctly? Did I convert that? All right. Yeah. Oh, I got a saw thumbs up. I thought it was a question. So now we're going to use our function. Our input parameter is going to be D. Nope, it's F, Kelly. F. Where's our length column? Where'd you go, buddy? Here you are. Why is there an error? Data has. Mhm. Oh, I think, is that what's happening? Oh, okay. Yes, yes, that's what's going on. That's what's wrong. I was trying to sign, yeah. D, I should have gotten rid of, I'm sorry. Do you guys see what happened? Anybody catch it? Okay, so we've been busy reviewing, having a fabulous time. And the data frame D is our batting data set, I believe. Yes. And so I was trying to assign 2026 values to a data frame that only had 1,384. And that is why I got this error, because it didn't match up. So if I don't want to assign it to the data frame D, I want to assign it to data frame F, which is our tiny fish. So if I just replace it, that was my error, we will no longer get an error message because everything matches up. And there we go. There's our image volume. What else did I say in this question? Oh, come up here. Volume answer for each parcel type. Okay, so I wrote this function and let's see here. We did it for each parcel. We just did it for everything. Okay. The next thing is right. Oh, that's what it was. I was like, this is its own question. I'm so confused. Come back here. All right. All right. So we want to convert the density here into individuals per cubic meter. Yeah, sorry.
So for that previous question, you had some clause in there about for each parcel type using parcel type factor. Wants to divide that and find an average for each, or was the answer?
The answer provided was sufficient. Let's see here. Assign.
Like when I read that,
You thought you needed to like aggregate.
well, I did provide.
Yeah, yeah. That was not great writing on my part. So I completely would have accepted that answer because it was you had done, yeah. Yeah. So hopefully you guys saw this a little bit in the exam. I fail sometimes at writing good questions, but like in this case, as Simon has pointed out, like there was some confusion. And so like the goal here is for me to see if you can write a function. So if you're going to do that and you get the function part writing, go forth and conquer. Okay. Okay. We want to convert this density, which is individuals per cubic meter, to individuals per 1,000 cubic meters. This is very simple. We could just do this in one line, but we'll write a function just to practice. You guys check my work. Sometimes these can be sneaky. I think this is right though. There we go. That's it. Yeah,
Divided by 1,000, right? 1,000. What you're asking for 1,000 power small.
no, I'm asking for, okay, so if you have like one, let's make it simple. If you have one fish per cubic meter, right? And you want to know how many fish are in 1,000 cubic meters. Why would you have fewer fish?
Right, so 1,000 divided by.
Okay, this is a unit thing. All right, let me think about this. All right. It's all right. Right? I'm just writing this out. This is a unit exercise. Okay. And do. You guys got me all goofed up now.
So once it's able, I can see, yeah, I can see both of them now.
Yeah, we usually do this for plankton because like the number is super tiny.
One per 1,000.
No, it's like total number of fish per 1,000. Yeah,
So using that density in a thousand.
yeah. With this part or the top part? Oh. So guys, we are at time. If there, did you get what you needed? Okay, so go back up here. Okay, the only thing we didn't get to was matrix and arrays. That's pretty straightforward. That's just like, you're just gonna have questions about making arrays and extracting things. You guys know how to do that. I know you do. So, okay, I will post this online and you will get your exam on Thursday. You'll have a couple days to do it just like before.
Submission is Monday or Sunday?
Would you prefer Sunday or Monday? Sunday it is then. This is what I did. Hang on, put your computer down. Let me just slide this over.
Okay, so I
tried a bunch of stuff for this and eventually I just created this for number one and did that. It's above the yes question mark. Because I got an answer. Because I was,
Okay,
I was
I
trying to
under-
convert the other way instead
Oh,
of
yeah,
converting
yeah, that's
those.
fine. That's fine. Both are
Um,
valid. Okay, I got you. So you
So
did
does
this.
that work or does that all need to be in the function?
No, well, this is fine.
Okay.
You're just doing math there. So you have executed this correctly.
Okay.
Yeah.
And then for the second one, this is what I did, well, dividing, not multiplying, but this is what I did for that. I didn't have a return and I didn't assign that to an object and I still,
You don't have to use a return.
okay,
I just default to returns. Return is used when it becomes necessary. Let's say you make multiple objects in like your function here. Like let's say you had an X, Y, and a Z, right? And you want to specify, I want to return only the value from the Y.
okay,
That's when it becomes required. When you just have one, it defaults to the last. Essentially what happens is it defaults to the last expression run.
okay,
So you only have one expression, so it's going to return Y regardless.
okay. And then I didn't do the third part because I lost on if I need to use a different, like, does this go in there to split it up? Or like, is that part of the last class or am I just completely crazy?
So, I am purposely trying not to put any text strings in here.
Okay,
So I want you to basically split this up. It's a
Mhm.
number, right?
mhm,
So if you wanted just the whole number, could you just subtract?
yeah,
Okay.
So Thursday is the no class, right?
What? Thursday, I'll put that on the thing, but there's no in class on Thursday. Yeah.
When I put a schedule meeting,
Yes, let's look at my calendar. Hang on, let me stop recording.